Hello, class. Welcome to 6.2b, Systems of Equations with the Substitution Method. So day 2, taking a look at this. Okay, so just a little review of what we're doing. The first step we need to make sure is one of your equations is solved for x or y, which is going to set us up to, for step 2, which would be to substitute and replace that variable with that. And again, you could, little note there, everything will be one variable. So what that's going to then do is allow us to solve for that variable. So that'll get you part of your answer. And then once you get the first part, then we go back and substitute back into an original equation to solve for another. Okay. And again, most cases are going to be one solution. But if you find out that some of your x's cancels or your y's cancel, and we're left with two numbers that do not equal each other, that's going to set us up for a no solution. If your x and y does cancel and all you're left with is number 1 equal to number 2, that would be a sign that this is going to be an infinite solution. Okay, so let's take a look at some examples. All right, taking a look at example 1, it appears that both of these have y equals. So we just need to pick one of these and substitute it in. So if we take that 3x plus 9, we will put it into that first equation. So that 3x plus 9 now equals 2x plus 7. And this is going to set us up to solve. So if we subtract by 2x, we now have x plus 9 equals 7. If we subtract by 9, x equals negative 2. So that should be first part of our answer. And now we need to plug this back into, really either of our equations. So I'm just going to plug that in, say 3 times negative 2 plus 9. That's going to get negative 6 plus 9. So negative 6 plus 9 is going to tell us that y equals 3. And that's our answer. So we're going to look at negative 2. Y is 3. And they are going to intersect at the point negative 2, 3. All right, let's take a look at another one. All right, this example here, y equals 3x. 5x plus 2y equals 44. Well, the top one is already solved for y, so let's substitute that y in. So that's just going to allow us to replace the two y, specifically the y, with a 3x. And 2 times 3, that's going to make that 6x. These are like terms, so add those two together. And then lastly, this is going to set us up to divide by 11, and x equals 4. When we substitute this one back into one of those originals, looks like the y equals 3x is going to be a little bit easier. So let's plug in 4 for x, and that's going to tell us y equals 12. So our answer here is 412. And that's all we got. All right, next one. Okay, this third example here. Now we're looking at them, and it looks like the top one is solved for x already, so that's good. So what that's going to allow us to do is let's substitute that in. So when we look at that bottom equation, we're going to say 5y minus 1. That's replacing the x plus 2y to equal 13. And now this is going to allow us to solve because you can see we have like terms, nothing to distribute. So we can kind of just ignore those parentheses for this one. And then that's going to set us up to solve. So add 1 to both sides. Divide by 7. And that's going to tell us y equals 2. And then we go up here to plug it back into one of our originals. It looks like that top one's going to be a little bit easier, because all we have to do is 5 times 2 minus 1. So really that's trying to say, what is 10 minus 1? Our x value is 9, so put those two together. and they intersect at the point 9, 2. And our last example. Now, both of these equations, neither of them are solved for x or y. So we're going to have to just solve to make sure we do force them. So I'm going to take a look at that first one. So if we need to rewrite this, we are going to solve for y. It's going to be a little bit easier. It's already by itself. And all we have to do is add 4x to both sides. And y equals 4x plus 4. Now we can go back and substitute the 4x plus 4 in for y. So if we look at 2x plus 2, now we are going to have to substitute in for y because we know that y is equal to 4x plus 4. And now we can solve. So distribute. This is going to allow us to add like terms. And now we can start solving. Oh, that's minus 8, minus 8, minus 8, minus 8. So 10x equals 5. Divide by 10. And x is going to equal 1/2. Okay, not too bad of a fraction. And if we go back to plug in, looks like if we're going to replace 1, it's going to be easy. This one we kind of rearranged. If we plug in what's 4 times 1/2, or what's 1/2 of 4, which is going to make y equals 6. So our answer is 1/2 and 6. All right. And that's it for today. So let's take a minute to kind of take a look at our practice. So pause here and practice a few of these. Be on the lookout for some of those special cases as you practice. And then check your work. Okay, so in that first example, you can see right off the bat again, what we're going to look at is those x's cancel. But now we have a 0 is not equal to 16, so that's going to end up as a no solution. Okay, the rest of them kind of work out pretty well. Looks like we got to do a little distributing and be careful with your negative signs and really just kind of check your work. And again, your answer or your work might not match exactly what I have, depending on which numbers you substitute where, but we should end up with the same answers. So check your work and make sure you come to class with any questions. And the last two, double check your work. And make sure anything on Canvas is done and called up. All right, guys, good luck. Have a great day.